All right, let's discuss cardiac muscle. Cardiac muscle is also involuntary, referring to the fact that we cannot control it. And unlike smooth muscle, though, it does have a striped or striated appearance. Now, another thing to note with cardiac muscle is it is going to have a branched shape, as you can see here. And the joining of those cardiac muscle cells together is going to occur at this white line right here, which is referred to as an intercalated disc. And this intercalated disc is actually a communication spot for these cells. This is something we're going to get into when we talk about the absolutely just spaced my words. This is something we're going to talk about when we talk about the cardiovascular system, because these intercalated discs are what allow the cardiac muscle cells to contract as one. Now, based on the name, it should hopefully be self-explanatory that this is going to be found only in the heart. These muscle cells are going to be uni or binucleated, so they're going to have one or two, but not more than that. They are far more responsive than the smooth muscle. Think about how quickly your heart rate can change depending on what you're doing. If you are, well, actually, here's an experiment for you. Go ahead and get up for me and do a couple of brisk laps around whatever room you're in, and then notice your heart rate speeding up as you move. Then sit back down and consciously start to take deep, slow breaths, and notice how fast your heart rate slows back down. That's how responsive that is. We are going to have sarcomeres and T2 involved here with the cardiac muscle. Now, again, we will explain why those are important when we get into the contraction phase. As I mentioned, the intercalated discs, they are junctions of those cardiac muscle cells, and they are going to be involved in the communication between the cells, and so they're going to have desmosomes and gap junctions located within them.